Everything we'll do here will be recorded, and I'll give you a file tomorrow morning of it, Taylor.
Okay, thank you.
You're welcome. So
Okay.
this is how this is going to work. Whoops. Only if I can get this thing working. Anyway, I don't need to draw anything on these yet. So let's talk about domain and range. Domain refers to which axis?
The x-axis.
Okay, so when you're looking for domain, you want to train your eyes to look left to right, left to right.
Okay.
When you're looking at range, which is the y-axis, you train your eyes to look up and down.
Okay.
All right. So what's the domain of A?
-2, 1.
Okay, and let me see if I can get this thing going again because, yeah, here we go. There's a certain way you want to write this. I assume they want you to use interval notation?
I have no idea.
Okay, let me teach you interval notation if you don't know what it is.
Okay.
Now, you use a bracket when it's a solid dot. You use a parentheses when it's an open dot. In other words, what this says is that x can take on values anywhere from -2 to 1, but not including 1. X is not allowed to be 1.
Okay.
That's what that open dot means, and that's what this parenthesis means. And infinities always are parentheses, never brackets. If it was all real numbers, that's what it would look like. That's not the answer for any of these questions. But anyway, that is the domain. Okay, so we'll call that the domain. Now, what's the range?
+2, 1.
Train your eyes to look up and down only. So what is the y value right there?
1.
And you're always starting from bottom and going to top.
Okay.
You gave it correct. You just went from top to bottom.
Okay.
And interval notation, what is it?
So it's
That's a bracket or a parentheses?
a parenthesis.
Actually, it's a bracket. Y can be minus or Y can be 1.
Okay.
In other words, when x is -2, y is 1. So
Okay.
it can be 1, and the top end of that interval is what?
2.
And parentheses or bracket?
Parentheses. No bracket.
No parentheses. It's the open circle.
Oh, yeah. Okay.
In other words, whenever you're looking at an open circle, doesn't matter domain or range, both of them are going to have parentheses. And closed circles mean brackets.
Okay.
But the key is this goes from left to right on domain, and range goes from bottom to top.
Okay.
So number B, domain is what?
The domain is -1.
Okay, also precede it with bracket or parentheses. In other words, let's use interval notation.
Okay, so it's a bracket, and then -1, +2, and then another bracket.
Okay. The beauty of interval notation is sometimes you'll have multiple intervals. There won't just be one interval. I could have a range on the left side and a domain on the left side and a different domain on the right side, and then you get to combine those in one statement with, are you familiar with this? That you?
No.
You ever use that? Okay. Well, I'm not sure how they want you to answer these if they haven't taught you interval notation, but that's the most convenient way to do it, is interval notation, so let's just use it. There
Okay.
are various ways to say this. The problem with normal notation is, notice that on the first problem, how do you say that? -2 to 1, but it doesn't make it clear that it can't be 1, and it can be -2.
Okay.
So that's the beauty of interval notation also, is it tells you whether it can be that number or just go up to that number.
Okay.
And the range, bottom to top.
So it's negative, or bracket, -2, comma 2, and then another bracket.
Correct. And that point right there, it can be -2. That's neither closed nor open, but it's clearly touching -2.
Yeah.
That tells us it can be -2.
Yeah.
And number C, domain.
So it would be 0 with a bracket, and then +2 with a parentheses.
And range.
And then range is, so would it be 0, or it would be
Parentheses or bracket? Always start there.
bracket.
Okay, we're starting here, right? And we're working our way up.
Oh, yeah, yeah. So parentheses, and then -1, and then +2 with a bracket.
Perfect. Okay. Let me scroll down to the next set of problems. All right, when you are talking about, well, this is going to cover a couple of things, these problems. So
Okay.
let's just go through one problem and do all 3 points. For the distance form, the distance between them. What's the distance between, on A? That's an easy one. That doesn't take much work. In other words,
9.
what we're looking at is 4, 1 and 4, 10. So it's just the difference, it's the difference in the y coordinates, right?
Yeah.
So correct, the distance is 9. Now, you can't use that easy of a solution if it's not a horizontal or a vertical line. In other words,
Yeah.
in B, we don't have a horizontal or vertical line, we have a diagonal line. Then we have to use the distance formula.
Okay.
This, find the equation through them. Again, A is not the norm. I don't like the fact that they started A the way they did. They should have done the more normal ones first and then introduced you to vertical and horizontal lines. But the equation of that vertical line. Vertical lines have equations that look like x equals. Horizontal lines have equations that look like y equals. And that's it.
Okay.
Y equals a number for a horizontal line. X equals a number for a vertical line. So what's the number? What's the number going to be? Remember what that point is. 4, 1. And that point is 4, 10. So we know it's x equals something. Because it's a vertical line. What is it? X equal what?
X.
What's the x coordinate that it's going through?
4.
Yeah, both of them.
Yeah.
What that basically says is that it does not matter what y is, x is 4.
Okay.
X is 4 when y is 1, x is 4 when y is 10, x is 4 when y is 1,000,000. Okay.
Yes.
And I didn't really mean to indicate that this line stops at those 2 points. when they say find the equation for the line, they're really referring to the equation that goes all the way to infinity in that direction and that direction.
Okay.
Okay, they're not referring to those lines we saw in the previous problem that have very finite domains.
Mm-hmm.
Okay. Okay, B is a better problem because B you have to use the distance formula.
Okay.
Now, the way to remember the distance formula, you graph these 2 points. 10, 2, it's about there. 2, 22, I'm going to put right there. Okay, I'll go ahead and label them. 2, 22, and 10, comma 2. Notice what that line almost always is it's the hypotenuse of a right triangle that I could draw in there.
Okay.
And so the distance formula is the Pythagorean theorem. It really is. It looks complicated, and most people don't really realize that it's the Pythagorean theorem, but it's the difference in the x coordinates squared plus the distance between the y coordinates squared. In other words, that's the Pythagorean theorem, right? If I let that be A, B, and C, we know that C, the distance C, well, we know that C squared equals B squared plus A squared, right?
Yeah.
Which means C equals to the square root of B squared plus A squared.
Okay.
Well, there's A. That is, well, I got it backwards, but it doesn't matter since we're adding. But this right there is the base of that triangle, x sub 2 minus x sub 1.
Mm-hmm.
Well, what is x sub 2 and what is x sub 1 in our problem here?
X2 is 2.
Okay.
And then X1 is 10.
Okay. And it doesn't matter which way you do the subtraction. Whether you get 8 or minus 8 isn't going to matter because notice we're going to square it. So
yeah.
We get the distance equals the square root of 8 squared. That's this part.
Uh-huh.
Plus what? What's the difference in the y coordinates?
Plus 24 squared.
The difference. Remember, that's a subtraction right there.
Okay. So 20.
Correct. So that's 20 squared.
Mm-hmm.
Now, if I was drawing it over here, this side would be 8. This side would be 20.
Uh-huh.
So you would merely apply the Pythagorean theorem, but rather than have to always go to the Pythagorean theorem and work from there, they want you to memorize the distance formula. Straight out that C is, the distance is the square root of the change in x's squared plus the change in y squared. That might be terminology you've never seen, but if you think about it, that's what we're doing.
Yeah.
Okay, so our distance here is going to be the square root of 400. That's what 20 squared is. And 64, which is 8 squared. So now let's go over here on the left. Leave your answers in simplified radical form. Let me erase some of this so I have a little more room to write. How can we reduce the square root of 464? What you do not want to do is use your calculator to do it.
Okay.
Because your calculator will give you a decimal answer, unless it's a whole number.
Mm-hmm.
I can't think of what whole number squares to 464. But let's practice our algebra and how you reduce radical form.
Okay.
You want to break that number up. You want to factor it into two numbers, one of which is a perfect square number. Okay? Over here on
Okay.
the left, I'm going to write perfect square numbers. 4, 9, 16, 25. Notice that's 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. That's usually as far as you need to go.
Okay.
So, is this 464? Are any of these numbers a factor of that? And you could use your calculator for this if you want. You could try to divide it, but let me suggest an easier way.
Okay.
First of all, a number is divisible by 4 if its last two digits are divisible by 4. Always. That could be 4,064.
Yeah.
Because 64 is divisible by 4, I know that whole thing is divisible by 4.
Yeah.
So I'm going to do that because I know that's 2.
Mm-hmm.
And then the rest of it is 116. 4 times 116 is 464. So now we've reduced it to 2 times the square root of 116. And the question is can I do any more? Well, is that number divisible by 4?
Yes.
Yeah, 16 is, so I know 116 is. So now I'm going to do this.
Yeah.
I'm just going to keep dividing it until I can't divide it anymore. 4 goes into that 29 times. Okay? Now, that's another 2. 2 times 2 is 4. 29 is a prime number, so there's no way I can simplify that anymore. There's your difference right there. 4 times the root 29.
So that's the distance?
That's the exact answer.
Okay.
Now, there's another part here. In other words, so far, all we've done is determine the distance and put our answers in simplified radical form. Now we have to find the equation for the line through them. Okay? That's a whole nother thing. Doesn't really have anything to do with the distance between them.
Yeah.
What's the most important thing about the equation of a line? Always is, always will be, all the way through calculus. First of all, what is the standard format? What is the slope-intercept format for the equation of a line?
I have no idea.
Y equals what? Got a ring. M?
MX plus B.
See, you did have an idea. You just didn't know it. That is called the slope-intercept format for a straight line. Because B is the Y-intercept. And M is the slope. So, I'm going to work on question B again, and we'll go back to A afterward. No, we did all of A. We even found the equation of the line for A.
Yeah.
We need to find the equation of the line for this. So when you're looking for the equation of a line, the very first thing you want to get is the slope. You want to solve for M first. Because notice that we don't know where that crosses the y-axis. Even when we graphed it, it's going to be hard to figure out where it crosses the y-axis. So what is the slope going to be? What's the definition of the slope? The word definition? This is what you want to remember, because you'll never forget this. You might forget the exact definition, but the word definition is what?
Rise over run.
That's the one you always want to remember.
Okay.
Because what's the rise? The rise is the distance between the y coordinates, correct?
Yes.
It's this distance right here, from there to there. So that becomes y2 minus y1. That's that distance. And the
Okay.
is what?
And then x2 minus x1.
Now, here it does matter that you keep the order of these the same. You can actually do y1 minus y2 as long as you do x1 minus x2. So you can reverse them, but you got to do both of them if you're going to reverse them. Sometimes it's easier to do y1 minus. Notice that it's easier to do 10 minus 2 than it is 2 minus 10.
Yeah.
But if I do that, I'd have to do 2 minus 22, so I've created the same problem. So try to use this formula unless it's a situation where it's clearly easier to reverse them.
Mm-hmm.
What's the slope here?
The slope is...
Just plug in numbers for starters. But don't try to do all the math. Just plug in. What's y2?
22. And then 2, so it's...
And x sub 2?
And then it's 2 minus 10.
So that gives us 20 divided by minus 8.
Mm-hmm.
We can simplify that. That's 5 halves. Slope.
Yes.
That's a negative 5 halves.
Okay.
And the negative sign is very important. There's a big difference between positive slope and negative slope.
Mm-hmm.
So we still don't have b. Now, let me ask you something. Have you been taught the point slope format?
No.
You sure?
I don't think so.
Well, let me give it to you, and you tell me if you recognize it.
Okay.
And you're going to see why this is going to be valuable. So, if you're doing the point slope format, notice that we only need 3 things. We need m, which we have, and we need 1 point only. I can use either point.
Okay.
I'm going to use the smallest numbers, okay?
Okay.
The equation of that line becomes y minus, well, that's y sub 1, 2, equals the slope minus 5 halves times x minus x sub 1, 10.
Okay.
So when I know a slope and 1 point only, I can very easily come up with the equation of the line. And that is actually the final answer. You don't always need the equation of the line to be y equals.
Okay.
In other words, you don't always have to put it into this format, slope-intercept. In fact, when you get to calculus, this is the only thing you use, is point slope. You don't use slope-intercept.
Okay.
But I don't want to get you confused with teaching you something that your teacher hasn't taught you. So for the moment, we're going to erase this method, and I'm going to show you how to solve for the same exact equation of the line using this formula here. Okay?
Okay.
So far, we know that y equals minus 5 halves was the slope times x plus b. Well, if we can figure out what b is, we'll have our answer. But it's a little more complicated. Notice that when I had point slope, I plugged it in and I had my answer instantly.
Yeah.
This case, I can solve for b, but I still have to pick a point and substitute it for the y and the x, and then I'm going to be able to solve for b. So if I pick that same point I'm going to let, when y is 2 and x is 10, this has to be true.
Yeah.
Because that line goes through this point. And what this is going to allow me to do is figure out my y-intercept. Okay, if I do the math here, that's a 5. So I get 2 equals minus 25 plus b, which means b equals 27. Now I know everything in that. What's my final equation?
So it's y equals negative 5 over 2x plus 27.
Exactly.
Okay.
That's really the hard way to figure out the equation of the line.
Yeah.
The point slope method gives you this same answer. It may not look like it's the same answer, but it actually is. I'll show you. It's just not manipulated to the point. We had y minus 2 equals minus 5 halves x minus 10, right?
Yes.
What I'm saying is those are the same two equations. Well, if I do the math, I get y minus 2 equals minus 5 halves x plus 25. Bring the 2 over, I get y equals minus 5 halves x plus 27, same thing.
Okay.
So either method gets you the equation. Now, if your teacher says, give me the answer in slope-intercept format, you got to do this method. Or you could use the other method and just solve it all the way out, like I just did. In other words, go from this step to this step. But if your teacher says, doesn't matter how you give me the equation, then you can get that in one step, and that is your answer.
Yeah.
There's no rule in math says that the equation of a line has to be in slope-intercept format. It's perfectly acceptable for it to be in point slope. And that's what this format is point slope. It's called that because that's exactly what you have, is a slope and one point. Whereas up here you have a slope and you know the intercept.
Okay.
All right. So, again, I don't like teaching people a new method and then they get confused when they go back and they have to use the old method. But, so until they teach you the point slope format, let's stick with the slope intercept format. Even though it's slightly harder, it's what I would expect your teacher wants you to use on this test or these problems. Okay. Actually, we're the half hour is up. We didn't get to cover all that much today because we spent a little bit of time getting you started. But you should have a good idea how this works. And,
yes.
I will email you a link to the recording of this file.
All right.
Either tonight or tomorrow morning. And
all right. Sounds good.
you can review it, and then I will talk to you at your next scheduled appointment. Now, the next time is all I'm going to do is text you the meeting ID number. If you look at your desktop, can you bring your desktop up? In other words, instead of looking at my desktop, if you look at actually, while we're looking at my desktop, you see where I'm pointing, this orange flower-looking thing, go to meeting? Yeah. You should have one of those on your desktop.
I do.
So the next time, you don't have to go to that website. You just have to double-click on that and put in the meeting ID number that I text to you.
All right, perfect.
And I'll text it to you just a couple of minutes before the scheduled session.
All right, sounds good.
All right. Taylor, I'll talk to you next week. I think that's when our next one is, right?
Yeah, on Monday.
Monday? Okay. Talk to you then. To close out the go to meeting, just click on the X in the upper right corner. All right. Talk to you then. Bye.
All right. Bye.